Okay, so let us proceed with problems 4 to 6. A solid shaft is used to transmit 40 kilowatts at 800 RPM. Compute the diameter of the shaft in mm to sustain a maximum deformation. So meron kang deformation na sinasabi dyan. Yung theta, T, L over J, G. Okay, simplify pa natin yan. T, L over pi over 32 G d to the fourth. Yan yun. Okay ba? Pi over 32. So, nandito yan ha. Binigay ko na dito yan. Yun sa ano niya. Yung J. Ayan o. Nabigay ba dito yung J? Sa torsion? Mhm. Wala pala. Yun lang yung J nun ha. Pag solid. Pi over 32. D to the fourth. Ito naman is bibigay ko naman lahat sa inyo ng ano, ng notes. Kaya huwag kayong mag-alala. Okay? Let us proceed. Number 4. So, tapos power ulit. That is torque N over factor. Commonly, hindi naman binibigay dito yung torsion. Okay? The diameter ang hinahanap. So, ipasok ko na yung torsion dito. Diyan. So, theta. Ulit-ulitin nyo lang para ma-familiarize kayo. So, P times F times L over N. Diba ito yung torque? Times pi over 32 d to the fourth times G. O, ito na yun. Simplify mo pa. Equal yan sa 32 P F L over pi N d to the fourth G. O, yan lang. Ganyan lang kasimple. Okay? Dire-diretso ka na lang. So, that is theta. Diba? Ang hinahanap mo dyan, sir, is the diameter. O, ito, diameter ka. Punta ka dyan. O, diameter equal to. O, yung fourth root. Fourth root. O, 32 P F L. Tapos theta pi. Okay, N G. O, ganyan lang. Napakadali lang. Pasok mo na agad yung value. Ay, wag ko munang lagyan nito ha. Para hindi nakalilito. So, 34, 32 times the power in kilowatts naman. Okay? Ang hinahanap ba dyan? A length of, okay, may length ka na 2.75 meters. In mm, SI na lahat yan. 32. The power is 40 kilowatts. 40 kilowatts. Tapos factor, that is 9,549. 1, 2, 3. Newton, millimeter, RPM per kilowatt. Tapos the length to 2.75, multiply mo ng 1,000, 2.75 times 1,000 para maging mm. Dapat lahat naka-mm eh. Okay. And then theta, naka-radian na ba kagad yan? O, 0.05 radian na kagad. 0.05 radian, di mo na kailangan mag-multiply ng pi over 80 kasi radian na. Times pi times n at 800 RPM. Tapos yung G, ano bang modulus of elasticity ng solid steel shaft? Steel yan ha, steel shaft. Solid steel shaft. Steel, ang ano dyan is 80. 82, pwede na rin. 82 na lang, 82. Or 83, pwede rin yun. 82, 83, pareho lang yun. Times 1,000 Newton per millimeter squared. GPA, naging MPa. Okay? So, to the fourth root. Ayan. Cancel muna natin yung same units. Okay? Kilowatt, kilowatt. Yung Newton, Newton. Yung RPM, RPM. Yung radian, okay na yan. As is na lang. Ang natira is millimeter, millimeter, and then millimeter. Millimeter to the fourth. Okay? Cancel ko muna to. mm to the fourth. Pindutin ko na. Isang pindutan na lang sa calcio yan. Ganun lang kadali, sir. Ang paraan na tinuturo ko sa inyo ng solving is katulad dun sa board exam. Kailangan i-reform nyo yung buong equation bago nyo ma-solve. Okay, 32 times 40 times 9549 123 times 2750. Okay, minultiply ko na agad ng 1,000. 0.05 nasa ilalim. Shift pi times 800 times 82. Pwede rin 83. Okay, 82,000. Okay, the answer is, the outside diameter is 42.4981 mm. Approximately 42.5 mm. That is the value of D for number 4. Okay? Napakadali. For number 5, the induced stress on a solid steel shafting 50 mm in diameter and 500 mm in length is limited to 500 MPa. If the original temperature of the shaft is 50 degrees Celsius, find its final temperature. If its thermal elongation is, so alat yan, di ba? Thermal elongation, 12.5 times 10 to the negative 6 meter per meter degree Celsius. Dapat to millimeter eh. Tignan nyo nandito yung formula niyan. For thermal elongation, okay, nandito siya. Ayan, okay? Ayan, thermal elongation nandito. Parang wala. Ayun, alat. Ayan, sa alat. Ayan, alat. Deformation due to heat. Kaya lang, nagbigay din siya ng deformation. Okay? Bigay din siya dito ng deformation. Induce stress, oh. May stress ka dyan. Deformation. Nung, hindi thermal, deformation to elongation. Okay? Equal to PL over AE. Limited to. Okay? Ibig sabihin, equal din yung kanyang naging thermal elongation dito sa thermal stress. 500 tapos equal to sa alat. Okay? Tignan natin dito yung formula. Ayan, ST, alat. AL delta T. AL delta T. Ayan yun. Pag makita nyo, ST. ST, stress. Thermal stress, EAT, heat. Okay, lista natin. Yung thermal stress is heat delta T. Okay? Ang stress equal naman yan sa induced stress on a solid shaft is okay, yung pala yun. Nagbigay ng stress, hindi pala ito gagamitin natin. Wala siyang binigay na elongation, kaya hindi pwede. Wala rin siyang binigay na force. Okay? Wala siyang binigay na L. Meron pala. Ay, meron. Tapos meron ka sa area. Okay? Huwag na natin gamitin yon. Ito na ang gamitin natin. Yung stress daw niya, induced stress dito due to the basta yung stress na yon equal dun sa thermal stress. Okay. So, equal yan sa 16 T torque over pi d cube. Yun yun. May torque bang binigay dyan? Wala. Wala kang torque na binigay. P over A. Induced stress. Okay. Induced stress, hindi pala siya. Hindi pala siya. Hindi pala siya. Torsional stress. So, induced stress, that is P over A lamang. Ayun. Okay? So, EAT, induced stress. Okay. Ito yung A. Ito yan. Tapos, 500 mm length. Tapos, 500 MPa. Okay. Sobra-sobrang binigay 50 millimeter in diameter and 500 millimeter in length. Is limited to if the original temperature on the shaft is 15 final hmm, LE. Ano bang gagamitin ko dito maganda-ganda? PL over AE. Ito rin kasi is stress din 'to. Okay, solve ko na, solve ko na. Equal lang yung kanilang deformation, okay. So, this one, tignan niyo, ito is the induced stress. 'Di ba force over area is stress? Na-stress ako dun, Yan. As may length, may E kasi solid steel shaft yan, eh. Ayun, so solid steel shafting. So that is, anong hinahanap diyan? Final temperature, delta T. Okay, dito na tayo babase. Delta T is equal to, cancel mo na yung L, cancel mo na 'to, okay? Meron kang stress divided by A. Itong A na 'to. Okay? So, meron kang PA, 500 MPa. Okay. That is 500 MPa over yung A, which is, what is the A? Ayun, 12.5 times 10 to the 6th. 12.5 times 10 to the negative 6th. Dapat to okay, yung thermal niya dito. Dito yan eh. Ayun, English. SI tayo. GPA. Okay. Degree Celsius. Oh, tama, tama. Cancel na rin naman eh. Cancel na rin naman siya. Degree Celsius, negative 1. Yan. MPa, MPa. Delta T. Kaya nagkaganon. Alat. Tama ba ako? PL over A. Yung kulang ako ng E sa baba. Yan, kulang ako ng E. Times solid shaft, that is GPA 207 times 1,000 MPa. Yan. So, masolve ko na yung delta T. Okay? Solve ko muna yung delta T. 500 divided by 12.5 10 to the negative 6. Okay? Times 207,000. Cancel na yung MPa, lalabas din Celsius. That is 193 ayun. Delta T is 193.2367 degrees Celsius. Ngayon, ang initial niya, final temperature, that is 50. Delta T is equal to T2 or T final minus T initial. Okay. So, TF is equal to 193. Okay, 193.235237 minus 50. Okay, degree Celsius. The answer is minus 50. The answer is 143. 143.2367 degrees Celsius. That is for problem number 5. How about problem number 6? A hollow steel wire daw, 8 feet long with inside diameter of 3/4 inch. So DI, 3/4 inch. And wall thickness, 1/8 inch. Supports a tensile load. Tensile, okay. If the stress is not to exceed, ito yung stress mo, and total elongation. So elongation, that is PL/AE. Hindi naman sinabi yung weight. Tapos meron kang stress dyan, tensile stress. That is force over area. Wala kang force, okay? Pwedeng ito, elongation, tensile elongation, that is P/A, that is ST/L/E. Okay? Compute the maximum tensile load in tons. So, itong hinahanap, tensile load P. Okay, P. 8 feet long diameter wall thickness. Area. Hinahanap dun, maximum tensile load in tons. Okay, yung ST ang hinahanap. Steel wire, yon. Okay. So, gulo ah. Compute the maximum tensile load. Dalawa. Dalawa ang babasihan mo. Babasihan mo yung maximum tensile load based on the elongation or the maximum tensile load based on the tensile stress. Okay, basihan muna natin yung sa tensile load mo. Dito muna tayo, basihan muna natin 'to. Since given naman si ST. So the maximum load, try natin based on maximum tensile stress. Yan. Based on maximum tensile stress, basihan mo yung tensile stress mo na. Naka 0.425 times 1,000 Newton per millimeter squared. Multiplied to the area. Yung area natin is pi over 4. Kaya lang, that is hollow. Okay. Hollow. Wala kang DO. Isolve natin si DO. Is equal to DI plus 3/4 plus twice nung 1/8 para makuha natin. I think this is 1/4. 1 ang lalabas na DO mo dyan. 0.75 plus 2/8. 1 to. Sure ako. Okay, that is 1. Tama. Bale, 1 inch. Square mo na lang. Square. Minus yung DI mo 0.75 squared inches squared. Kaya lang ang problema mo dito naka-inches squared. Okay? O di multiply mo ng 1 inch squared 25.4 mm. Square mo na lang to. Ayan. So based on the maximum, lagi mong babasihan yung maximum ha. Bigyan natin. 0.425 times 1,000 times shift pi over 4 times squared, kasi 1 lang naman yan, minus 0.75 times 25.4 squared. Okay. That is the in newtons. 94215 newtons. 94215.92 newtons. That is based on the tensile stress. How about based on the maximum elongation? Now, hinahanap mo si P. Okay? P, Pauline na ayaw kay Andrew E. That is the elongation AE over L, the length. Okay? Hindi natin alam yung maximum. This is based on elongation. Ganyan po mag-solve pag strength of materials. Hahanapin mo yung kung saan siya dapat ibase. Kung sa elongation ba, sa loading, or sa tensile stress. So, ang ano niya, elongation niya is half an inch. So, P, half an inch is 0.5 inch times 25.4 mm, 1 inch. Tapos area pi over 4 times 25.4 squared minus, times ko na agad, 0.75 ng 25.4. That is 1905. 19.05 squared mm squared. Yung E ng steel, that is 207 times 1,000 Newton per millimeter squared divided by the length. Ano ba yung total length? 8 feet. Gawin nating meters. 8 feet times 3.28 feet, 1 meter, times, in mm dapat, 1,000 mm, 1 meter. We cancel all the same units. Yung inch, inch, mm, mm squared, meter, meter, the feet, the feet. Okay? And then we'll arrive with newtons. Ayan. Okay? 0.5 times 25.4 times pi over 4 times 25.4 squared minus 19.05 squared, okay, times 207 times 1,000. Actually, pwede na natin i-cancel yung 1,000 kasi may 1,000 din dito eh. Okay? 8,000 by 3.28. The answer will be, di mas malaki yung loading kapag meron kang elongation. P is 23894, 2.4405 newtons based on elongation. Okay? Yan. That is based on elongation. 1/2 inch ba naman ang ano mo, in-extend mo. Okay? That is for problem number 6.